let's look at the concept of force-coupled systems. And to explain this, let me start with showing a rigid body. So this is, again, a body that does not deform under forces, and let's say that is a block, right? And that block, let's say that is somewhere in a space, or perhaps is a block on ice, so there is a little friction with the floor. And let's say that we have a force that is applied in that corner. Now, we can say that if this is a rigid body, we can slide that force in its line of action, right? And again, the line of action will be anywhere in this line. And then the effect on that rigid body will be the same. The external effect on that rigid body will be the same. Once again, I want to emphasize that we're making the assumption that that is a rigid body. So what I'm going to say is that this is equivalent to having the same rigid body, and let's say to have the force over here, right? Same force F. Make a diagram here that this is a rigid body, right? Same thing. Why are these two equivalent? Because if you think, for example, about this point in this left bottom corner, if you do some of the moments, or you do moments of that force about this point, it's going to be the same thing of the sum of the moments of that force after sliding in the line of action about this point, right? It's going to be the same value. The reason is because the perpendicular distance to the line of action is going to be the same, right? So externally is going to have the same effect on that rigid body. Now, the next question is, can we actually move that force outside the line of action? And, well, not really, right? So what happens if we want to have now our rigid body, and instead of having the force sliding on the line of action, we're going to move it perpendicular to that line of action. So let's say that this over here is going to be that force, right? Now what happens is, if you look at the moments about a point, let's say about this point, this had a positive, negative moment, right? F produced a negative moment about this point A, let's say, right? At the same point A. And in this case, at the bottom, it produced no moment about point A. So by moving the force not along the line of action, we're going to have a different effect, external effect on that rigid body. All right, so what can we do to be able to make these two equivalent? Well, what we need to do is we need to add a moment, right? Add a moment, and I'm going to do that moment with this symbol. And by adding that moment, now the system on top and the system at the bottom are going to be equivalent. So these two now are going to be equivalent. Okay, so if you're sliding the force in the line of action, no problem, you can slide it. If you're doing something that is not in the line of action, you're moving it, then you're going to have to add a moment to that force, and that is a force coupled system, right? This moment can also be a couple, right? All right, so this is the main idea. You can move it in the line of action, no problem. We don't need to add any moments. If we move it any other way that in the line of action, we need to add a moment to find an equivalent system. All right, so how does that work? Well, let me explain this. So what happens is, let me do a parenthesis here. So why did we arrive to that idea of that moment? Well, let me once again do the the rigid body with that original force. And what I'm going to do is I'm going to add two additional forces that will add to zero, okay? I'm gonna add one force right here of the same magnitude of our original force. And I'm going to add a second force. Let's see, I can do green, second force right there. Apply both of them at A, and the three forces have the same magnitude, right? Okay, so now let's see what's happening. Now what's happening is that this force and this force over here are a couple, right? So I can actually represent that couple with that moment and in here, and this is going to be the same thing as saying that I have my block with the force that is remaining after the couple, right after I take out the couple, and I'm replacing those two forces by this moment M. So this is how we end up with that moment. This is how we end up with that moment. So once again, the main idea of the main concept is if you're gonna move a force in the same line of action, you can slide it, no problem. It's gonna have the same effect in that rigid body. If you're gonna move in perpendicular to the line of action, then what we need to do is to add a moment. Now, what is going to be the value of that moment? Well, the value of that moment is the value of that couple that we had at the bottom, right? And as we learned before, if the distance between these two forces, between the line of action of these two forces is d, right? That moment is going to be f d. And of course, we have to use positive and negative based on our right hand rule, right? So very, very simple. We know the distance that is perpendicular to these two lines of action of those two forces, right? Actually, of this force and this force. Then we can calculate the moment by doing plus or minus based on your right hand rule, the force times that distance.